This is question number 1. Part A, the line L1 passes through the point 5, 2 and makes an angle of 135 degrees with the positive direction of the x-axis. So that's this line here. The first part of the question asks us to find the equation of L1. In part B, we're told that L2 is perpendicular to L1, so that's this one here, and passes through the point 6, -3. It then goes on to ask to find the coordinates of P, the point of intersection of L1 and L2. So ultimately the question wants us to find the meeting point of those two lines, the point of intersection. What we need to remember is to do that, what we need to do is simultaneous equations, or substitute one into the other, make them equal to each other and so on. In order to do that, what we'll need to know is we'll need to know the equation of the straight line L1 and the equation of the straight line L2, and that's what we'll need to do in parts A and B before we find point P. So first thing we'll do is we'll give ourselves a bit of room. So what we're trying to do is find the equation of L1. That's a straight line. So the things we need to know are the gradient and a point on the line. So for L1 we know that the point passes through 5, 2. We're told that in the question. We then need to find the gradient. Now we should realise that the angle they give us 135 degrees, which is the angle with the positive direction of the x-axis. That should lead us to remember to use the formula m equals tan theta, where m is the gradient of the line and theta is the angle between the line and the positive direction of the x-axis. So that means we'll be able to find the gradient m by doing tan 135 degrees. To do that, we'll separate this off with a wee bit of working at the side and give ourselves a bit of room. So first of all, we should know that tan 135, if we don't have a calculator, we can still work that out using our cast diagram. So putting the quadrants in, all sine, tan, cos. If we measure 135 degrees, that would take us round to the sine quadrant, somewhere in here. So 135 degrees, which means we don't need a calculator. We can use our exact values table to work out the angle, because we know that the angle associated with 135 is 45 degrees, this one in here. So what that actually tells us then is that tells us that tan 135 will be equal to tan 45. The only thing is we are in the sin quadrant, which means it will not be exactly the same. It means tan 135 is equal to negative tan 45. So from our knowledge of the exact values table, we should know that tan 45 is 1, which means negative tan 45 is negative 1. So that then gives us our gradient to put back in over here. We know that m equals negative 1. That was the other thing we needed for our straight line, which means now we can go ahead and use the point and the gradient to work out the equation of the straight line. So substituting into the straight line formula, y minus b equals m bracket x minus a. So that's y minus 2 equals negative 1 times x minus 5. That then gives us y minus 2 equals negative 1 times x is negative x, and negative 1 times negative 5 is plus 5. So we'll put it into the form y equals, because that will be handy later on. So that's negative x plus 5 plus 2, which then gives us y minus x plus 7. So that's the equation of L1 and the answer to the first part of the question. Now part B, we know that what we're going to have to do there is find the equation of another straight line, L2. So moving on to that part, what we have for this straight line is a point. We know it passes through 6, negative 3. In order to find the equation of a straight line, we'll need to know the gradient also. We are given some information. We're told that this gradient, this gradient is perpendicular to the one that we have already found. So we know that the gradient of the line we've already found, we'll call that L1. We know that the gradient of that line is -1. That means that therefore that the gradient of the line we're looking for now, L2, is just going to be that number flipped upside down with the sign changed. So that means our new gradient is just 1. So the gradient of the line we're trying to find at this point in time, L2, is 1. So now we have a gradient and a point for our line L2, which means we can work out the equation of the line. So substituting those into the straight line formula, y minus b equals m bracket x minus a. So that's y take away -3 equals 1 bracket x minus 6. So that gives us y plus 3 equals 1 times x is x, and 1 times minus 6 is minus 6. So making it y equals x, take away 6 minus 3, which means y equals x minus 9. So that's the equation of line L2. What we have now is we have two straight line equations, which means we can find the point of intersection. So L1, line 1, was y equals -x minus 7, and line 2, the one we've just figured out, was y equals x minus 9. So the easiest way to find the point of intersection here, because they're both in the form y equals, we can simply make them equal to each other. So -x minus 7 equals x minus 9. So rearranging, we'll bring the numbers to the left and the letters to the right hand side to avoid negative signs. That gives us -7, and bringing the 9 over gives us +9. We have x on this side already, bring the negative x over and that becomes plus x. So -7 plus 9 is 2, which equals x plus x, which is 2x. So that means 2x equals 2, which means that x equals 1. Now we know our x value. It's just a case of substituting that back into one of the lines to find the y value. So we'll take our x value and we'll substitute it into line 2. So line 2 was y equals x minus 9. So y equals, we now know x is 1, so that's 1 minus 9. So that means y equals -8. So we have our x value and our y value, which means we have the point of intersection, point P, and that's the point 1, -8. Our final answer. Question number 2. Mr. Smith, a biology teacher, had a feeling that his locust colony was dying off. One day he counted the locusts and discovered that there were only 3,600 left, and that he was losing them at a rate of 15% each week. He decided that something had to be done. He bought a fresh supply of live locusts and started adding them to the colony at a rate of 240 each week. The new locusts were introduced at the end of the week. Part A set up a reconciliation to illustrate Mr. Smith's locust situation. Part B then says that Mr. Smith decided that if the number of locusts in the colony fell below 1,800, he would need to abandon the colony and start again. Then Part B says, over the long term, would Mr. Smith ever have to abandon his colony? You must show all relevant working and give a reason for your answer. So Part A, we need to set up a reconciliation to illustrate the situation. So the general form of a reconciliation is simply un plus 1 equals a times un plus b. So we are told in the question that he's losing 15% of his locusts each week, which leaves us with a multiplier of 0.85 un, and he is going to introduce 240 locusts at the end of the week, which is plus 240 over at the end. So that gives us a reconciliation for the situation we have. If we look at part B again, we're asked about, over the long term, would Mr. Smith have to abandon his colony? So when reading that, you should immediately realise that what you want to do is calculate the limit. So first of all, we know that a limit definitely exists, and that's because our multiplier A, which is 0.85, it lies between 1 and minus 1, so therefore a limit exists, first of all. So since the limit exists, we can then calculate the limit to find out what happens in the long term. So writing down a limit formula, L equals B divided by 1 minus A. So B, as we know, is 240 and A is 0.85. So that's 240 divided by 1 minus 0.85. That then gives us 240 divided by 1 minus 0.85 is 0.15. Now, assuming that this would be a non-calculator question, we can do this division, 240 divided by 0.15, first of all by making it a little easier for ourselves. So we multiply the top and the bottom by 100. That will get rid of the decimal on the bottom. So that gives us 240, and then add 2 zeros for multiplying by 100, and 0.15 multiplied by 100 is 15. So it's still quite a tricky division, but we can easily do some working at the side to find out what the answer actually is. So we'll set that up over here. We've got 15, and we're seeing if that goes into 24000. So 15 into 2 doesn't go, so carry the 2 onto the 4. 15 into 24 goes once, with 9 left over, so carry that on to give 90. Then 15 into 90, that goes exactly 6 times, and then 15 into 0 and 0 gives us 1600 as our answer. So that means our limit is 1600. We were asked, over the long term, would Mr. Smith ever have to abandon his colony? And the answer to that is yes, since the limit is 1600, which is less than the 1800 specified in the question. He would need to abandon and start again. Part of the graph of y equals f of x is shown in the diagram. So that's this curve here. We're asked to sketch the graph of y equals f dashed of x plus 2, marking clearly any known points. So the f dashed of x in here tells us that what we're going to sketch is the derivative, and the plus 2 here tells us it will then be moved up by 2. So in order to sketch the derivative, we'll use a technique that we've looked at before. So before we do that, we'll zoom in a little bit. The first thing we need to do is identify the stationary points on the original curve. That's this one here and this one here. These stationary points will help us identify where the new graph cuts across the x-axis. So if we come down onto the x-axis, this point here, which I'll indicate with a red dot, tells us where our derived function will cross the x-axis. And this stationary point, if we bring it upwards to the x-axis, indicates a point, again, where the derived function will cross the x-axis. What we need to do now is look at the gradient of the original function. In this part of the original function, the curve has a positive gradient. So we'll indicate that on the curve with plus signs. In between this point and the next stationary point, the graph then has negative gradient, which we'll indicate with negative signs. From the secondary stationary point onwards, the graph then has a positive gradient again, so we'll indicate that with plus signs. Now the plus signs and minus signs indicate the gradient on the original curve, but on the derived function, sketch, the plus signs indicate that the curve is above the x-axis, and negative signs indicate that the curve goes below the x-axis. So working our way from the left, up till this point here, the original function has positive gradient, which means the derived function will be above the x-axis. On the original function at this point, the gradient then goes negative in between here and here, which means on the derived function, the function has to go below the x-axis. Now, because we know that the curve is going to pass through this point again, that means we should know that it will have to curve back up to get to this point. Now, on the original function at this point here, the gradient then becomes positive, which means on the derived function, the curve then goes back up and above the x-axis. So we can quite clearly see that the derived function is a parabola, which means it's a quadratic. There's no way of knowing with the information we're given how far this turning point comes down, whether it's below or above this one, so we just need to sketch it as best we can. What we do know for definite is we know that these 2 points here can be identified. So this point along the x-axis is -1 at this side and 1 at the other side. So what we have sketched here is the derived function f dashed of x, but the question isn't complete because we're actually asked for the function y equals f dashed of x plus 2. So the blue curve now needs to be moved up 2 places, so we'll give ourselves a bit of space here to do that. So keep this one up here so we can see it. I'll then draw the y-axis and the x-axis in again, like so. Now the blue curve, I'll then move it up 2 places, so I'll try and sketch this as best as I can. Again, we don't know how far down that turning point will be, so we'll just put it like that. What we do know are that the 2 points on the x-axis, -1 and 1, will now be moved up. So that gives us 2 points here. This one will now be -1, 2, and this one will be 1, 2. The sketch we have now is the one we're looking for, y equals f dashed of x plus 2. And that's the end of the question. Question number 4. Two functions are defined on suitable domains as f of x equals 4x plus 5 and g of x equals x squared plus 3. Part A of question 4 asks us to show clearly that h of x equals 16x squared plus 40x plus 28. We're told that h of x is the composite function g of f of x. So the first thing we'll do is we'll write down the two functions that we have. So f of x, first of all, is equal to 4x plus 5, and g of x is equal to x squared plus 3. What we are trying to find here is we're trying to find h of x, which is the composite function g of f of x. So what we have here is we have the f of x function substituted into the g of x function. So that means what we're doing is we're actually taking 4x plus 5, which is the f of x function, and we're substituting it in anywhere we see an x on the g of x function. So that means instead of x squared in our g of x function, it's going to be 4x plus 5 that gets squared in there. Then we have our plus 3. So what that means is we have to square out our bracket, so I'll bring the equal sign over here, which gives us 4x plus 5 multiplied by 4x plus 5 with our plus 3 on the end. So we'll multiply this out in full, so that's 4x from the first bracket multiplying the second bracket, then plus 5 from the first bracket multiplying the second bracket, plus 3. So 4x times 4x is 16x squared. 4x times 5 is 20x. 5 times 4x is 20x. 5 times 5 is 25. And then we have our plus 3. So if we simplify what we have now, we have 16x squared. 20x plus 20x is 40x. And 25 plus 3 is 28. So we were asked to prove that, so we have proved it, and that's the end of part A. So we now look back at the question to see part B. Part B says, or asks us to find the values of x for which h of x equals 4. So we know now that h of x is the function that we've just written down. H of x is equal to 16x squared plus 40x plus 28. So we just proved that. We want to know the values of x which make h of x equal to 4. So that means 16x squared plus 40x plus 28 equals 4. So what we have now is an equation which we can solve by collecting everything to the left hand side. So we'll bring the 4 over alongside everything else. That gives us 16x squared plus 40x plus 28 take away 4 equals 0. Simplifying, we have 16x squared plus 40x plus 28 take away 4 is plus 24. So we now have a quadratic equation that we can solve. The first thing we should do is take out a common factor. 8 is the common factor. 8 times 2x squared gives you 16x squared. 8 times 5x gives you 40x, and 8 times 3 gives you 24. So what we're going to do now is solve for x, and we'll do that by factorising the quadratic. So we'll have 8 as our multiplier. We'll put our double brackets down, equal to 0. So what we'll do is we'll set out a little bit of working over here at the side for this. So we'll put down 2 brackets. What we're trying to do first of all is get 2x squared. So we do that by having 2x in one of the brackets and x in the other at the front. Then we move to the opposite end. We need 3 in here. So that means we need 2 numbers to multiply to give you 3. So the only options are 1 and 3. So what we can do is try 3 in here and 1 in here. Do a crossover working. 2x times 3 gives us 6x, and x times 1 gives us x. So we need these things here to give us a plus 5x in the middle. So if we make it plus 6x and minus x, that gives us the plus 5x that we need. So 2x and 3 multiplied to give us plus 6x, which means the 3 has to be positive. And 1 and x multiplied to give us negative x, which means the 1 has to be negative. So that means we have the 2 brackets. We just need to put it back into our main set of working. So we'll bring that back over. So in our brackets we have, it was 2x minus 1 and x plus 3. So that means either 2x minus 1 equals 0 or x plus 3 equals 0. So for the first one, that means 2x equals 1, which means x equals 1 over 2 1/2. Or for the other one, x plus 3 equals 0, which means x equals negative 3. And those are our 2 possible values for x, so that h of x equals 4. Question 5, part A. The curve in the diagram has its equation in the form y equals kx times x minus 4 all squared, where k is a constant. We're told that the curve passes through the point 5, 10, which we can clearly see on the diagram, and we're asked to find the value of k. So what we're going to do is we're going to take our point and we're going to substitute it into our equation and solve for k. So first of all, we'll write down our equation. So that's y equals kx bracket x minus 4 all squared, and then our point on the curve, the point 5, 10, x is 5 and y is 10. Substituting that into our equation of our curve, we get 10 equals k times 5 minus 4 all squared. So that's 10 equals k times 5 multiplied by 5 take away 4, which is 1 squared. So that's 10 equals k times 5 times 1 squared, which is 1. So that's k times 5 times 1, which is 5k. So that means 5k equals 10, which means k equals 10 divided by 5. And 10 divided by 5 gives us k equals 2. So part A asks us to find the value of k, and k equals 2. Part B of the question asks us to find the equation of the tangent to the curve at the point where x equals 1. So in this part of the question, what we're trying to do is find the equation of a straight line. A tangent is a straight line. So the things we need for that are the gradient of the straight line and a point on the straight line. Now, the only information we're given is that the x coordinate is 1, so we can put that in for a point, which means we've got a couple of things to work out. We need to work out the y value of our point, and we need to work out the gradient. So the simplest thing to do first is to work out the y coordinate, which goes with the x coordinate equal to 1. So we'll do that by substituting back into the original equation. So the curve equation is y equals 2x bracket x minus 4 all squared. We want the y value to go with the x value of 1, so that's 2 times 1 times 1 minus 4 all squared. So that's 2 times 1 times 1 minus 4, which is negative 3 squared. So that's y equals 2 times 1 times negative 3 squared is 9. So that means y equals 2 times 1 times 9, which is 18. So that then gives us our y value to go along with the x value, which completes our point. So we'll substitute that in up here. What we need to do now is work out our gradient m. As soon as we mention gradient, we should realise that what we need to do is differentiate our equation. And in order to do that, the first thing we have to do is prepare it for differentiation. So our original curve equation is y equals 2x bracket x minus 4 all squared. So to prepare it for differentiation, we must remove the brackets, which means it's going to be 2x times x minus 4 times x minus 4, which is y equals 2x multiplied by x minus 4 times x minus 4. So multiplying those two brackets gives us x squared minus 8x plus 16. Now that we have multiplied the two brackets out, we need to multiply all of that by 2x, which then gives us y equals 2x times x squared is 2x cubed. Then 2x times minus 8x is minus 16x squared. Then 2x times 16 is 32x. We now have something that's ready to be differentiated, so we can go ahead and do that. So dy by dx equals 3 times 2 is 6x, take 1 away from the power is 2. 2 times 16 is 32, and then just x, removing 1 from the power, and then just 32 at the end. So what we have now is this thing here, which represents the gradient of our curve. We know we want to find the gradient when x is equal to 1, so that means m, our gradient, will be 6 times 1 squared, take away 32 times 1 plus 32. Which means that our gradient m is 6 times 1 squared, which is 6, minus 32 times 1, which is minus 32, then plus 32. The minus 32 and the plus 32 then cancel out, which means our gradient m is equal to 6. So now we know our gradient, we can put that up here alongside the point. So we now know m equals 6. That means now we have enough information, point and the gradient, to substitute into a straight line formula. So we'll do that over here. So our straight line formula is y minus b equals m bracket x minus a. So that's y take away 18 equals the gradient, which is 6 times x minus 1. So that's y minus 18 equals 6 times x, which is 6x. Take away 6 times 1, which is 6. Collecting everything to the one side, we get y minus 6x minus 18 plus 6 equals 0, which means y minus 6x minus 12 equals 0, the equation of the tangent. So moving on to part C, we'll have a look again at the question. Part C asked us to find the x coordinate of R, the maximum turning point of the graph. So that's this point up here. So we should realise that that's a stationary point. There is already one other stationary point which we know is down here at x equals 4. In order to find the stationary points on a curve, we should know that we need to differentiate our curve and set it equal to 0, then solve for x. So we'll do this over here. So first of all, we'll state that what we need to do is find a derivative, set it to equal to 0 for stationary points. So a derivative which we actually worked out earlier in the question is 6x squared minus 32x plus 32 equals 0. So we can take a common factor of 2 out here. That gives us 2 times 3x squared minus 16x plus 16 equals 0. So we're then going to factorise the quadratic into double brackets. So we'll do that here. We'll do a bit of work on its side. In fact, we'll do it over here. So we'll put one bracket above the other. So we have one here and one here. The first thing we're looking for is two things to multiply to give us 3x squared. So that means we need 3x in one of the brackets and x in the other. Then we need to think of two things that multiply to give us 16. So there's quite a few options for that. If we pick the correct one straight away, it should be 4 and 4. So to check that that is right, we'll do a crossover working. 3x times 4 gives us 12x, and x times 4 gives us 4x. What we need to do is combine these two things now to give us negative 16x in the middle. And we will do that if we have negative 12x take away 4x for minus 16x. So we multiplied 3x and 4 to get negative 12x, which means it has to be negative 4. And we multiplied x and 4 to give us negative 4x, so that means this one has to be negative as well. So putting those two brackets back into our main set of working, do that over here. So that gives us 3x minus 4 and x minus 4, which means 3x minus 4 equals 0, or x minus 4 equals 0. So that would be 3x equals 4, which then means x equals 4 thirds, or x equals 4. Now, if we look back at the graph, we already knew that one of the stationary points was at x equals 4. So we'll have a quick look at that. That was this one here. So that means we can rule out that one. We're looking for point R, which is this one up here, which means it must be the other one of our stationary points. So going back to what we got there, the two stationary points were at x equals 4 and x equals 4 thirds. This one here is the one that we already have, so we can rule that one out, which means x equals 4 thirds is the x value of our point R. We're not asked to work out the y coordinate, so that's our final answer. Question number 6. Solve algebraically the equation 2 sine 2x plus root 3 equals 0. And we're told that our solutions x have to lie between 0 and 360 degrees. The first thing we should notice is it's actually 2x in here. So that means we'll have to rewrite our interval for our solutions. So instead of x, it should be 2x in there, which means we have to multiply each of the values by 2. 2 times 0 is still 0. 2 times 360 is 720 degrees. So that's our interval for our answers for 2x. So I'll write down the equation that we're working with. It's 2 sine 2x plus root 3 equals 0. So in order to solve that, we have to rearrange. So first of all, 2 sine 2x equals, and move root 3 to the other side, which gives us negative root 3. Then sine 2x equals negative root 3 over 2. So we should recognise that root 3 over 2 is one of our exact values. We ignore the negative sign at this point, whether we're using our calculator or our exact values table. It's not meaningless. We will use it for our cast diagram in a moment or two. So our cast diagram, all sine tan cos. The fact that it is negative here tells us that our answers are going to come from the opposite quadrants from sine, which are the tan and the cos quadrants. So the value root 3 over 2 should tell us that our associated acute angle is 60 degrees. What that means is that our answers for 2x, we'll move this up a bit, 2x are, first of all, in the tan quadrant, it will be 180 plus 60 degrees. And in the cos quadrant, it would be 360 take away 60 degrees. So that means our answers for 2x are 180 plus 60, which is 240 degrees, and 360 take away 60, which is 300 degrees. Now at this point we need to remember our interval for our 2x solutions, and it went all the way up to 720, which means if we add 360 to both of these, it will give us two more solutions. So 240 plus 360 gives us 600, which is still within our limit, and 300 plus 360, which is 660 degrees. Now we could keep going getting more values by adding 360 to these two, but that would then take us out with our interval for 2x. Now the question is not finished because we want to solve for x, which means we need to divide each of these by 2, which means x equals 240 divided by 2, which is 120 degrees, 300 divided by 2, which is 150 degrees, 600 divided by 2, which is 300 degrees, and 660 divided by 2, which is 330 degrees. You'll notice that all our four answers fit within the original limit x lying between 0 and 360 degrees. Question number 7. One of the first things we should realise when reading through this question is that it is in fact an optimisation question. We're told that an open-topped animal drinking trough is in the shape of a prism with a semicircular cross-section and dimensions y by 2x shown here in the diagram. We are then told that all dimensions are in centimetres. A part 1 says, given that the volume of the trough can be calculated using the formula V equals a half pi r squared h, show clearly that y equals 2v over pi x squared. So if we look at the diagram, we should notice first of all that the diameter of the semicircle is 2x. That then means that the radius would be half of that, which is x. Also, if the trough were standing upright, the height would be the distance from here to here, which means h in our formula is in fact y. So if we can take our formula, write it down, rearrange it, then hopefully we'll be able to show this one here. So that's what we'll do first of all. Our formula, V equals 1/2 pi r squared h. We know that r is, the radius is x and h is y. So that means V equals 1/2 pi x squared y. This can then be rewritten as y equals, and instead of 1/2 pi x squared y, we can make that pi x squared y over 2. If we move the 2 to the other side alongside the v, that will get rid of the fraction, which gives us 2v equals pi x squared y. We can then flip that round the other way and write it as pi x squared y equals 2v. So that means that y would be equal to 2v over pi x squared. That's what we were asked to prove, and we'll finish the first part of the question. Looking at a part 2 next, we're told that if the capacity of the trough has to be 7.2 litres, show that its internal surface area, A of x, is given by this formula here. Now, before we get into that, it's important to note something that was mentioned at the start of the question. All dimensions are in centimetres. So before we continue, we should rewrite 7.2 litres as 7,200 cubic centimetres. To determine the total internal surface area, we need to consider each of the shapes which make up the trough. So thinking about them one at a time, we have the semicircular end, which has a diameter of 2x. So we have in fact 2 of them, and then we have the curved surface area, which when flattened out is in fact a rectangle. So in order to find the area of the semicircle, first of all, area of a full circle is pi r squared. We have a semicircle, but since there are 2 of them, that would then make a full circle, so we can just go ahead and use the area of a circle formula as it is. So that means the area of both semicircular ends in total is pi times the radius squared. We know the radius is in fact x, so that's pi times x squared. So that's our area of both semicircular ends in total. Looking now at the curved surface area, which has been flattened out into a rectangle, we know the length from the front to the back was y. Now, if we're not careful, we might think that the breadth part here is 2x, the same as this here. But if you consider the diagram properly, you should realise that this length here is curved round, which means it is equal to this length here on the semicircle. Now on the semicircle, we can quite clearly see that that is part of the circumference, and since it's a semicircle, we know that it is in fact half of the circumference. Now the circumference of a full circle, C, equals pi times the diameter. A full circle would then be, in this case, pi times 2x, which means a full circle would be 2 pi x. What we have is not a full circle circumference, but just a semicircle, which means the length of the blue line is half of 2 pi x, which is just pi x. So what we have now is the length and the breadth of a rectangle. We can then use the area of a rectangle formula to write down the area of this part. Area of a rectangle is the length times the breadth. The length is y, multiplied by the breadth, which is pi x. So that means the area of the rectangle A equals pi x y. What that means then is that the total area, or total internal surface area, will be these two things added together. So the total internal surface area is written down as A of x, and the semicircular parts in total is pi x squared, adding on the curved surface area, which we now know is pi xy, gives us this. Fortunately, y is something that we worked out earlier in the question, which means we can now substitute that in. So a of x equals pi x squared plus pi x multiplied by y from earlier, which we found to be 2v over pi x squared. So what we can do now is multiply out that bracket. That then gives us a of x equals pi x squared plus, and then if we think of this as pi x over 1, it might make it easier. So that gives us pi x times 2v on the top, which is 2 pi xv, and then 1 times pi x squared on the bottom, which is just pi x squared. We can then cancel pi with pi on the top and the bottom, and then one of the x's with the x on the top, which then leaves us with a of x equals pi x squared plus 2v over x. We noticed earlier on that our volume was given in litres, which we then changed to cubic centimetres. The volume was 7,200 cubic centimetres, so we'll substitute that in for v. So pi x squared plus 2 times v, which is 7,200 over x, which then gives us a of x equals pi x squared plus 2 times 7,200, which is 14,400 over x. This is what we set out to show, so that's the end of that part of the question. Moving on to part B, so we'll have a quick read at what that asks us to do. It asks us to find the value of x which will minimise this surface area and give your answer correct to 1 decimal place. So what we're looking for here is the minimum stationary point, and as soon as we think of that, we should know that what we need to do is differentiate. So writing down our formula, it's a of x equals pi x squared plus 14,400 over x. In order to differentiate this, we first must prepare it for differentiation, which means bringing the x onto the top line. So we have pi x squared plus 14,400 x to the power minus 1. We're now ready to differentiate, so a dashed of x equals 2 pi x when we differentiate that, and then take away 14,400 x to the power minus 2. We can then rewrite this with a positive power, which would give us 2 pi x, take away 14,400 over x squared. Since we're looking for a stationary point, we know that the gradient has to be equal to 0, so since this represents the gradient, we can make this equal to 0 at this point. We're looking for the x value which will minimise the surface area, which means we're trying to solve the equation we have here. So the first step to doing that is, first of all, by moving the fraction to the other side. That gives us 2 pi x equals 14,400 over x squared. To get rid of the fraction and bring all the x's onto the left hand side, we'll take x squared over, which means it will multiply. That then gives us 2 pi x times x squared, which is 2 pi x cubed, and that equals 14,400. That means x cubed will be equal to 14,400 divided by 2 pi, which means that x will be equal to the cube root of that. So x equals the cube root of 14,400 divided by 2 pi. What we need to do now is do that on our calculator, and remember that the question asked us to give our answer correct to 1 decimal place. So if we do that, we find out that the answer is 13.2 centimetres, and that's correct to 1 decimal place. So that's the x value which will minimise the surface area. We have to show that this stationary point is in fact a minimum, and to do that we must use a nature table. So we'll set out our nature table down below. So we have x and our derivative a dashed x, which will indicate the gradient, and then underneath that the slope indicated by our positive or negative gradient. So setting out our table, we have our stationary point 13.2, which we are hoping is going to be a minimum, and we need a value before and afterwards. So often 0 is a good one to choose whenever we can, but in this case 1 is better. And then we'll choose a value bigger than 13.2, which is 20. Now the derivative at the stationary point will be 0, so we can fill that in before we begin. And in order to find the slope before and after, we need to substitute 1 and 20 into the derived formula, which was a dashed x equals 2 pi x minus 14,400 over x squared. The presence of the x squared on the bottom is the reason why we don't want to make x 0. So first of all, substituting 1 into this formula, we get 2 pi times 1, take away 14,400 over 1 squared. So that would then give us 2 pi times 1, which is 2 pi, take away 14,400 over 1. Now, we don't actually need to work that out to realise that that's going to be negative, because it's going to be 2 pi take away 14,400. So quite clearly 2 pi take away that will be negative, which means we can fill that in on our nature table. So that's a negative. And then the same thing over again, we're going to substitute the value of 20 in. So putting the value of 20 in, we'll separate that with a line. That gives us 2 pi times 20, take away 14,400 over 20 squared. So 2 pi times 20 is 40 pi. Take away 14,400 over 20 squared, which is 400. So cancelling down here, we get 40 pi, take away 144 divided by 4. So 144 divided by 4, 44 is 36. So again, we don't need to complete the calculation to realise that this is in fact going to be a positive answer. 40 times pi is much bigger than 40, and if we subtract 36, then obviously the answer will still be positive. So filling that into our table, that tells us then that this gives us a plus sign in here. That means our graph slopes downwards. The stationary point, it goes flat and then it slopes back upwards, which indicates that 13.2 is a minimum. That's us proved it's a minimum. We know the answer for x is 13.2, and that's the end of the question.